Hello again. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host. It is great to be back for another episode, and thanks for joining us. Now, what are we doing today? We're talking about a potential meteor shower. This is a brand new one. Whenever there's a meteor shower, you usually know about it because it's been happening for a long, long time, every year. This one, maybe never before, probably not. We'll find out. We're also looking at lost fruit in space. Yes, it's the Robinson family again. Maybe not. And life, straight after the Big Bang. Could it happen? Or could it have happened? We don't know, but someone thinks it might have. Plus questions about the Doppler effect and redshift and the slingshot or gravity assist effect. How does that work? We'll do all that today on Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me to solve all the mysteries of the universe in 5 seconds flat is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Sounds good. We'll solve everything between us.
Indeed we will, yes. Still trying to cope with the hot weather here. We are having another week of scorches, and it's been relentless. We haven't had a break in the weather for nearly 2 weeks now, which is ridiculous, and big numbers too. Over 40 degrees Celsius 4 or 5 days in a row out our way, which is just hellishly hot. Not fun at all. But you press on, don't you?
Well, yes, yeah, that's right. I do remember, when I lived not very far from where you live now, once in a while you got this succession of hot days. And this was before the days of air conditioning as well, which made it even worse. Terrible.
You tell the young people today that there was no such thing as air conditioning. I wouldn't believe you.
That's right. Quite so.
Yeah, I remember visiting my grandparents, and the only cooling system they had was one of those little indoor evaporative coolers that you had to keep filling up with water. And of course now they advertise those things on TV as super coolers, and everyone thinks, I've got to get one of those. In fact, we'll give you 2 for half the price. But they're just swamp boxes, just like the things from 50 years ago. So
pool of water with a fan on it, isn't it? Isn't that what it is?
That's basically it. Yeah, yeah. Because when we moved out here, because it's a dry heat area, they were very common, those evaporative coolers. Yeah. But they don't work so well anymore because the air's so much more humid these days.
Humid, yeah. That's right. That would make a change. That's certainly true.
Yeah. All right, we better get on with it, Fred. Let's talk about this potentially new meteor shower. When you say new, does that mean this one's never happened before?
We think so, yes. So just to recap on what causes meteor showers, they are what happens when the Earth passes through dusty debris left behind by a comet. So comets, as they go in their orbits around the sun, they get near the sun, their icy material evaporates, it actually sublimes, it goes straight from a solid to a gas. And what that does is, because comets are what we often call dirty icebergs, they're just blobs of ice with a lot of dusty bits in them, and sometimes rocky bits too, as the ice disappears, of course, it releases the dust, and so what you get is clouds of dust which follow the comet. In fact, you can see the dust trail of a comet. If you've got a particularly bright comet that leaves a trail behind it, you can actually see that, and we often see photographs of them with that dust trail streaming out behind. So there are a number of comets whose orbits intersect that of the Earth, which means that the dust trails they leave behind are actually in the Earth's path around the sun. And so the Earth charges into them at 30 kilometers per second because that's its orbital speed. And what you get is on the leading side of the Earth, you get these meteor displays. You get showers of meteors. And the reason why a shower of meteors is different from your everyday meteor, which is usually called a sporadic meteor, is that in a shower, the meteors all seem to come from the same direction in the sky. And that is because of what you've got is the combination of the Earth's velocity and the dust particles' velocity. And those two things conspire together to mean that they all seem to come from a single point in the sky as we watch from Earth's surface. And we call that the radiant. That's the radiant, the point from which the meteors radiate. And there are some very well-known ones. And in fact, there's one of the best-known ones is coming up within the next few days, our time. It's what I call my birthday meteor shower because it's on the 14th of December. And it is the Geminid meteors, and they seem to come from the constellation Gemini. So a lot of these are common knowledge, but now we have the prospect of a new one that hasn't been observed before. And it comes from a comet called Virtanen, Wirtanen, also known as 46P. Often these comets have got a name that has a P after it, which stands for periodic. It means it goes around the sun in a measurable period of time. Halley's Comet, for example, 76 years is its period around the sun. This one, though, Virtanen, is sorry, hang on. Something's just flashed across my screen that's totally taken my mind away. Yeah, let me get rid of that. Comet Virtanen has an orbital period of only every 5 years. That's fairly rapid. And that we think that these short period comets have interacted with the planet Jupiter, and that Jupiter is gravity, which kind of does lots of things to anything passing by. It shepherds them into a much shorter period orbit, because otherwise all comets would probably be one-offs. They'd just come into the inner solar system from way out in the depths of space, what we call the Oort cloud, swing by the sun and then go back again. With periods perhaps hundreds of thousands of years. So Jupiter has a lot to answer for when it comes to short period comets, and Virtanen is one of them. So it's got this short period orbit. I can't remember whether I said it was discovered in 1948, but that was when it was found. Now, some scientists in France, specifically at l'Observatoire de Paris, that institute has scientists who have wondered why we don't get a meteor shower from this comet, because its orbit intersects that of the Earth. And what they've done is they've actually looked in detail about the projected path of the dust particles and how they might interact with the Earth's orbit. And what they've got is the potential of a meteor shower, which actually is a couple of days before the Geminid meteors on the 12th of December. And they're saying that during the early part of the night, during the later part of the night, it's the early part of the night, universal time. But as always with comet displays, it's the later part of the night for astronomers. During the later part of the night, there might well be a meteor shower coming from the direction of a star, which is called, let me find the name, Lambda Sculptoris. That's a star in the constellation of Sculptor, a southern constellation. And so these meteors would be known as the Lambda Sculptorids. That will be what they're called if they happen. So the prediction is at the moment that this meteor shower will take place. It's never been seen before. Astronomers, meteor watchers, and there are people who are, big meteor enthusiasts, will be photographing them, will be attempting to photograph them, which will be should provide the evidence that that they come from this point, Lambda Sculptoris, which would define them as being part of that meteor shower. So it's a really interesting piece of work. I think we're blessed with good fortune for this particular display, as we are with the Geminids, because the moon is new effectively at the moment. So there's no moonlight. So people in dark skies should get really good views of these meteors.
And they do make spectacular photographs. I've seen some online over the years, and gee, you can get some great photos, especially if you I can't think of the term, but if you leave if you're in a dark enough area and you can leave the exposure open for a while, you can get these beautiful effects. Yeah,
that's right.
I think,
that was easy in the days of film photography. You just opened the shutter and let the camera do its thing. You needed a dark sky sight to do it. These days, the digital cameras need a bit of tweaking to do that. You basically end up taking a succession of relatively short exposures.
Interestingly, there is an app that can do all that for you these days.
And sure there is. Yeah.
I've got it on my phone, but I can't find it now, obviously, because I've got squillions of them. I haven't actually used it yet, but now I'm thinking this might be a great opportunity. But you just basically open the app and set the camera up, and then you just walk away and let it do its stuff for a while. Come back later and your photo's done. I think it saves a lot of trouble. I can't remember what it's called, but if I remember before the end of the show, I'll let people know. But I think I've been busting to use it and haven't had a chance yet. But I might be able to get out there in the next what's the next few nights you're talking about?
Yes, that's right. Our time, as we, actually, by the time we go to air on this broadcast, it will have happened.
Okay. So all right.
We might be able to tell. But actually, the Geminid meteors, they're spread over quite a few days. So anybody who wants to try and catch the Geminid meteors, which come from the constellation Gemini, the twins, of course, then listen in because if what's your name again, Dave? If Andrew finds the app, then it'll be worth playing with.
Yes, and now I'm looking again, but that's okay. It's fascinating though that we've got this new one. It must be rare for us to have these situations arise, especially given that this comet isn't the first time it's come through. It's been around for a long time, so.
That's right. I suspect what sort of happens is just as these orbits drift slightly, it may well just have drifted into such a position that we might start seeing meteor debris from the comet. So, I think it is, as you said, it's a bit of a milestone finding a new meteor shower.
Oh, I found it. Good. It's called Nightcap. Nightcap.
Okay. Right. Okay.
Is the name of the app. Nightcap camera. And that's the one that, you can basically set and forget for nighttime photography. So there you go. I had it in a folder. That's why I couldn't find it initially, but there you are. These next few days could be pretty exciting for those who want to do some astrophotography or meteor photography. Moving on, Fred, lost tomatoes on the International Space Station. This is hilarious. This story is funny.
Yes. Well, it goes back to, as you know, experiments on the International Space Station include growing things to see how things grow in zero gravity or microgravity. And some time ago, tomatoes were grown. And in particular, one of them was a rather nice-looking tomato that disappeared. One of the astronauts who was aboard the space station at the time, Frank Rubio, was always suspected as having eaten it, although he denied it.
And always denied it, yes.
Always denied eating this tomato, but everybody thought he'd eaten it. Now, meanwhile, Frank's gone back to Earth, but the current crew of the International Space Station, Frank went back to Earth a couple of months ago in September. And I think the accusations have all been pretty light-hearted that he'd eaten this space-grown tomato. And he said at the time, I spent so many hours looking for that thing. I'm sure the desiccated tomato will show up at some point and vindicate me years in the future. And guess what? It has done. This tomato has turned up, yes. Nobody's saying where it was or what its condition was, but yes, it's likely to be in a state of advanced decay there because of the conditions aboard the space station. So not only will we know...
How do you lose something on the International Space Station? I mean, okay, the other day they lost a tool bag, but that was outside.
Outside, yeah, that's right.
This was inside the cabin, and it's just it's vanished for 8 months.
I'm not surprised because when you look at pictures of the inside of the space station, it's all racks of equipment, scientific equipment, all in racks on the side walls of the space station. There's nooks and crannies everywhere, and things float around. So if it came off its stalk and just wandered off on its own, it could have wound up anywhere. And I'm not sure how big this tomato was. It probably wasn't that big, so it may have found its way into some tiny nook or cranny that nobody else could find.
Yeah, maybe it was one of those cherry tomatoes.
Could be.
Who knows? But they found it, so he's off the hook.
Off the hook.
I think that's hilarious.
Yeah, it's a good
fair
story.
income. I love it. I love that stuff, and it's it's good to see that even with something as serious as space flight and all the work they do on the ISS, they can also have a bit of fun. I saw a video this morning that somebody captured from an airport terminal of two Australians under a Virgin plane. One of them was giving the other one a golf lesson. It's great. I just thought it was great. Simple stuff, really.
Yes.
You just never know what's going to be filmed these days and what's going to end up on social media. So it's funny stuff. But this is a great story about the tomato. If you want to read more about it, it's all over the internet. It's been a big news story these last couple of days for sure. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, we have spoken many times.
It's all right. So keep going, Andrew. I've just got to answer your text, which won't take long.
That's okay.
Excellent. That's fine.
Fred's amazing because he can walk and chew at the same time. We have spoken. We've spoken many times about the Big Bang. We get question upon question about it. Not quite as many as we get on black holes and dark matter, but we do get a lot of questions about the Big Bang. And now there's a new theory that's been put up, I suppose you'd call it a theory, that life may well have been able to take hold very soon after the Big Bang. Well, define what very soon is. Are we talking seconds, hours, weeks, months, years?
Less than a second, Andrew.
Are they really saying that?
Well, this is it's a conjecture. What the point that's being made in this article, and it's a very nice article actually, by Paul Suter, who's a space.com contributor, living in New York City. He speculated. Well, first of all, as you kind of have to do when you start talking about life in space, you've got to define what life is.
Yeah.
For the purpose of this article, he takes kind of the broadest possible definition, which is anything that's subject to Darwinian evolution. In other words, something that can modify itself in response to, its environment.
Okay.
The definition that NASA uses is similar to that. If I remember rightly, it is a self-sustaining, there's two things to it. I've forgotten the other one. Self-replicating, self-sustaining entity that is capable of Darwinian evolution. That's the NASA definition.
Sounds like a disease.
And so it does. Well, that's right. And that's a really good question. Are viruses living organisms? It's one of the big debates of biology. But if you broaden the definition just to make it something that's subject to Darwinian evolution, then it actually does as Paul himself says, it blurs the boundaries between life and non-life. And that is interesting because there will be some chemical reactions that might well be capable of Darwinian evolution, even though they don't have anything like we consider to be parts of living organisms now, where you've got DNA and RNA and proteins and all of that stuff. That a chemical living organism would be really, it would not satisfy my definition of life, even if it was capable of some sort of evolution. I think robotic organisms might well be capable of that as well. In fact, what's that old hoary one, the von Neumann machine, which is supposed to be a machine that can replicate itself in space. These were conjectured decades ago, von Neumann, by somebody called Herr von Neumann. So the issue is a blurry one. But if you accept that broad definition that Paul does for his article, then you've got the possibility, as he as he relates at the end of his piece, that perhaps life could have existed very, very briefly in the aftermath of the Big Bang. And the reason why he's saying that is that our normal picture of the way life has evolved. You start with a Big Bang that within a few seconds makes hydrogen. Hydrogen's the raw material of stars. They collapse under gravity. Blobs of hydrogen collapse under gravity, make stars. Stars switch on by the high temperatures of that collapse. Nuclear fusion turns the hydrogen into other elements. And so we know that all chemical elements, except for hydrogen, helium, and there's tiny bits of lithium and deuterium, I think, are the two other ones that were formed in the Big Bang. Virtually all chemical elements come from the inside of stars, apart from hydrogen, helium. So to get stars, to have stars means that you've got the ingredients of life, the chemical ingredients of life. And the first generations of stars, as we know now, were within a few 100 million years of the Big Bang. They were very, very early on. And so you could get chemistry forming once those stars have spread their elements that have been formed in their atmosphere among the interstellar medium. Then you could get some sort of early what we would call prebiotic chemistry. In other words, the building blocks of life, and then something happens that makes that turn into living organisms. And usually living organisms involve the idea of lipids and fats, which let these organisms form membranes, so that they make little bags within which the chemical reactions can take place, and that then becomes a single-celled organism. That's the sort of picture, the broad picture that we've got of the way life forms. But he's, what Paul is saying is, he actually speculates quite widely and in an interesting way, because we, as you and I have spoken about many, many times, Andrew, 95% of the mass energy budget of the universe is stuff that we don't know about, dark matter and dark energy. And Paul speculates, as many have done before him, that dark matter might not just be one thing. There might be a complete periodic table of dark matter. And so maybe, there's dark chemistry playing out in the dark matter sphere. And so he hypothesizes that perhaps dark matter itself may spawn life, which he calls dark life. It might have appeared long before the first stars appeared, because you have dark matter, which might have its own periodic table, irrespective of the normal chemicals that are being produced in the nuclei of stars. So it is, it's a really broad view of the origin of life and where it might have gone. It's actually on the space.com website. Paul is writing for them. But at the end of his article, yes, he comes to the punchline. I'm just going to read what he says because I think it's rather well put. The possibilities can get even weirder. Some physicists have hypothesized that in the earliest moments of the Big Bang, the forces of nature were so extreme and so exotic that they could have supported the growth of complex structures. For example, these structures could have been cosmic strings, which are folds in space-time anchored by magnetic monopoles. We don't know whether they exist, but that's a good way to put it. And then he goes on, with sufficient complexity, these structures could have stored information. There would have been plenty of energy to go around, and those structures could have self-replicated, enabling Darwinian evolution. Any creatures existing in those conditions would have lived and died in the blink of an eye, their entire history lasting less than a second, but to them it would have been a lifetime. It's a very nice ending to his article. I'm not sure whether anybody will believe it. Yeah, but it's a fascinating theory, that's right.
Yeah, but he also suggests that life could have started forming on Earth before the Earth had finished developing, and that may have also happened on places like Venus and Mars. So there's other theories as to how and when life came about beyond that moment of the Big Bang. So I suppose it's one of the big mysteries of the universe. How did it happen? And as we said at the very beginning, how do you define life? I mean, I was driving up the street the other day, Fred, and I know this is going to sound silly, but I just looked at a row of trees and I thought to myself, why do we call them alive? Why do we, they don't have a heartbeat, they don't have brains, they don't, but they replicate. They develop and adapt to nature and the environment. It's Darwinian evolution, as you said. So that's probably the answer to the question. But when you really think about it, it's a very strange form of life, is a tree.
Yeah, it is. That's right. As a plants generally, they're very different from, the animal life that we're familiar with. But it's all part of life. And if we found a tree on Mars, you can bet your boots it would be the news story of the century, Andrew.
It would indeed. And I venture to say that with the search going on up there for evidence, maybe fossil evidence of life, even if that is discovered, that would be earth-shattering news to say, okay, we actually have found that life did exist on Mars. May still, don't know. And then the question arises, okay, is it the same kind of life as we have? Is the DNA the same? Or is this a completely different life form unrelated to Earth? And those are exciting questions. They really are.
They are, yes. So if you can, do a genomic sequence of a living organism from Mars and discover that it's got links with living organisms on the Earth, then you can bet your life that you're talking about the same source, something that has formed on one planet or the other, and some event, probably an impact event that's raised material. We know we've got meteorites from Mars. We know they come from Mars because of their chemical composition. Then that suggests that there's a common ancestor to living organisms on Mars and on Earth, which is itself an extraordinary thing. If it was ever, if that was ever found.
Yeah, and let's assume that's what will be discovered. It would then add a lot of potential to the possibility that the recipe for life is universal. Because if it's happened on Earth and happened on Mars, it stands to reason that this formula exists in many places beyond our solar system, perhaps, and life just needs the right situation to take hold and become established. Right. Yeah,
and that's particularly true in the case of if we did, do genome sequences of bacteria or something found on Mars, discovered that they were quite different from those on Earth, then that, I think, does point to the fact that wherever you get the right environment, you're likely to get life forming. because you've got two completely separate ancestral lines there, rather than them having a common ancestor.
I think if we discover life elsewhere, I know what life form it will be, Fred. I've already got that figured out.
I'm sure you have.
Well,
please fill me in.
The answer is weeds. Weeds. They just they grow anywhere and everywhere. They just pop up in places where you think, how on earth did you even establish yourself there and survive? So weeds is the answer. That's what we'll find.
Now, weeds would be very exciting, Andrew, because they are multi-celled organisms.
Yes, that's true.
And most astrobiologists think that what is more likely to be found is just slime, green slime, made of microbes.
Well, it depends on the star
which is
that the planet's attached to, doesn't it? What colour the slime will be.
Yeah, that's right. That's a good point.
Could be blue.
Might be blue.
All right. But it's a great article if you want to read about the theory as to when life might have happened in whatever form, space.com. And the article is titled, Life Might Have Been Possible Just Seconds After the Big Bang. It's a great read. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts.
It's time for a Q&A, Fred. This is where we take questions from the audience. And our first question comes from Rusty, who, surprisingly, is being very, wait for it, is being very brief.
Hey, Fred and Andrew. It's Rusty in Donnybrook. The LIGO and Virgo detectors is a detection of a gravitational wave, a Doppler change in the laser light. That's it.
Short and sweet. So did you catch all that?
Yes, I did.
Okay.
Yep.
So what's Rusty talking about first and foremost?
He's talking about those gravitational wave detectors, LIGO and Virgo, are what are called interferometers, which means that you have a beam of light which is being bounced backwards and forwards between two mirrors, and by letting light waves combine, you find that the waves of light either add together or cancel out. And that's the principle of what we call interferometry. It's this addition and subtraction of light waves. And so it means you can bring two beams of light together and get darkness. I've always found that an extraordinary capability, an extraordinary thing. But you're not just cancelling out the energy, because it goes into where the two waves combine, and basically you get a bright spot. So what Rusty is asking is the cancelling out and additional effect caused by as the gravitational wave passes through the detector, what it does is it changes the separation of the mirrors very slightly, tiny amount, 1/10,000th the diameter of a proton. It's crazy stuff. So it changes them, and what he's asking is it the positional change that is the important thing, or the speed of change?
Okay.
Which would give rise to a Doppler effect, which slightly changes the frequency. And it's actually the position. So the Doppler effect is even more minute than the position change, because the velocities with which the mirrors move are so tiny. But it's a great question. It is a great question.
They're always great questions from Rusty.
Yeah.
Even when he tries to trick us. Which is, Rusty, I'm no challenge, but
do that.
Yes, he would. Yes, he would. Thanks, Rusty. Always good to hear from you. Always insightful. Let's go to another question. This one from Robert, and this one is it's not unrelated to what Rusty was asking about, actually.
Howdy, boys. This is Robert from the Netherlands. I've got a question for you guys. Could you please explain to me the difference between the redshifts due to the Doppler effect as to the redshifts through light traveling to dust? I'm so curious to learn the answer. Hope things aren't too dusty in Australia. Thank you. Bye-bye.
Thank you, Robert. Things are very dusty in Australia. I got up this morning to go to work on the radio station and the sun was just rising. And usually I have to drive east for a little while before I can turn to go up to the radio station. And the sun literally hits me in the face first thing in the morning this time of year. This morning, it didn't blind me because of the dust in the sky. Because we've had a lot of wind around here lately. And so there's a lot of dust in the air, and it actually acted like a pair of sunglasses this morning. I didn't need my sunnies on because the dust through the horizon was so thick. I just got a sort of an orange hue effect rather than a blinding sunspot. So that was nice, actually. But it did show me that things are very, very dusty here at the moment, Robert. Yeah. So, another question asking about redshift, Doppler effect, or the effect of dust. Again, I probably need to please explain on this one.
Well, no, his question's great. Thank you, Robert, and very nice to hear from you again. The Doppler effect is basically the change in frequency or wavelength of something, whether it's sound or light, as an object moves with respect to the observer. And the classic example is always trotted out by people trying to explain the Doppler effect. It's a siren, a vehicle with a siren on it going past you, and you hear the siren change pitch as the whatever it is, the fire truck or ambulance or whatever, heads off into the wide blue yonder. We had a classic example of that here where I live in Davidson in northern beaches of Sydney a few days ago, when there was a house not very far from us which sadly caught fire and burned down, and we could hear sirens coming from all round the place. It was unbelievable. We didn't know what it was, but we could hear all these sirens, and their pitch was changing as their distance, the speed with respect to us changed. So something coming towards you, the pitch is raised, and what that means, if you think of it being light rather than sound, is that something coming towards you would have its light blue shifted, would be shifted towards the blue. And we can measure that with stars some stars are coming towards us. Likewise, something going away from us is redshifted. Now, it's slightly different, actually, from the redshift, what we call the cosmological redshift. This is the redshift of distant objects. The further away you look in space, with galaxies we're talking about now, not stars in our own galaxy, the further away you look, the more redshifted they are, and that's because of the expansion of the universe. The space itself, in the time that the light has been traveling through it, has stretched, and that stretching is what gives rise to the redshift, which is subtly different from a Doppler effect. It is just a slightly different thing. But you can lump those two together as being, physical properties to do with the wavelength of light or other radiation traveling through the universe. And the other thing that Robert mentions is the dust, exactly this reddening. We actually usually call it reddening rather than redshift. Yeah. And that's because what's happening is that the blue light is being subtracted. So if you've got light coming from a distant star, and that light passes through a cloud of dust, whether it's the same sort of dust as you've got or something a bit different, it's silica dust, actually, that we find in space. That dust cloud scatters the light. So as photons of light, individual particles hit the particles of dust, they kind of bounce off. But the blue light is much more preferentially scattered than the red light. So blue light bounces off in all directions. And whereas the red light largely continues through without being scattered too much. And so what you have, if you imagine yourself looking at this light that's come through a dust cloud, the blue light's gone off in all directions, but the red light's carrying on to you, then you've got a redshift, effectively. We call it reddening. And it's really convenient because you can numerically measure that reddening. You can work out what the light of the star would have been before it left. And then you can work out what has happened as a consequence of the dust cloud. And that gives you an idea about properties of the dust itself, gives you an idea of how big the dust cloud is, how much of this material it's come through. And that's a very, very powerful tool in astrophysics. So reddening by scattering, which is what the process is, rather than, Doppler effect or anything like that, reddening by scattering is a very powerful tool.
I got a, I don't know what you call it, on Facebook this morning, a reminder notice about something that I photographed 4 years ago. And I don't know if you remember, but we had those massive bushfires across the state, which basically shrouded the entire state in smoke. It was quite amazing. And when I got up early to go to work and the sun was rising this time of year, it was rising through the smoke, and it blocked the sun to a point where all I could see some days was a pink billiard ball or an orange billiard ball. The effects were astounding. I took so many photos of it, and they popped up today as a reminder. So I've reposted them on my Facebook page because I've never seen anything like it before. These huge circles of pink in the sky every morning that was just the sun, but because of the effect of smoke and those small particles, it wasn't scattering the light so much as it was blocking it, and all you were getting was the disk of the sun through in a perfect sphere, and it was bright pink. It's just amazing photos and amazing images just to drive. Like, I don't know how I didn't crash because I just couldn't take my eyes off it. It was astounding.
I can imagine.
Yeah. But I've got dozens and dozens of photos that I took of that effect. I was just going to bring it up now and see if I could find it for you from all those years. Yeah, there we go. Look, can you see that?
Yeah, hold your camera a bit, your phone a bit closer to the camera, Andrew, because at the moment it's overexposing.
Yeah, there it is.
Yeah, I got it now. Yeah, that's incredible.
And then, there's the one I was talking about, the pink one. So
yeah,
quite incredible. Yeah,
that's reddening in action there.
It certainly is. Yes, indeed. Did we finish answering Robert's question? I got distracted.
Yeah, I think so. Yeah.
All right. Thanks, Robert. Yeah. We have a text question, and this one comes from Paul in Victoria. Hi, Andrew and Fred. I have a question. Are you able to explain the details about how spacecraft are able to slingshot past a planet to travel faster? I thought this may be an interesting topic since we hear the term getting a slingshot, or gravity assist is another word for it, quite a lot, but never really get an explanation of how it works. In my mind, I struggle to get past Newton's third law, which is basically that for every action, there is an equal and opposite reaction. So the entry velocity would be the same as the exit velocity, which wouldn't cause a slingshot effect. Love listening to the podcast. Thanks, Paul from Vermont, Victoria, Australia, not Vermont in the other part of the world. Yeah, it's a good question. It's a very good question because I often wondered the same thing, Paul. So what's the answer?
Yes. And Paul's right. And, intuitively, you think, okay, something's being pulled towards a planet. You've got a spacecraft that's going past a planet. It's being pulled towards it by the planet's gravity. But then once it's gone past, it's being pulled by the same force. So that any speed increase it receives as it goes past the planet should be taken away from it by the gravitational pull of the planet as it leaves. And from the planet's perspective, if you think of the planet as, everything's moving with respect to the planet, that's the case. The incoming velocity or acceleration is the same as the outgoing acceleration. So Paul's synopsis about the third law is right. The two things balance out. What makes the difference is the fact that the planet is moving, and it's that motion that means that if you look at it in a frame of reference of the sun rather than the planet, then you've got an increase in velocity. And sometimes it's quite significant. The velocity of the planet is added. And what's actually physically happening is that the spacecraft is stealing some of the momentum of the planet as it moves around the sun. So it grabs a little bit of that momentum, and that gives it the slingshot boost. But the amount of momentum that it's stolen is so small, the planet doesn't notice it at all.
Yeah.
But the spacecraft does, because its mass is so much less. And so you've got this really very, very useful physical adjunct to rocket fuel. You can make it far more economical to get spacecraft to where you want it to be. And there have been some classic missions that have involved, half a dozen or more.
Voyager would be a classic example.
I think Voyager was only 4. It might have had interactions with the Earth itself, though, which might add to that. But Cassini, I think, had 6 or thereabouts, something like that. Yeah. Sometimes, you bounce it off the same planet several times to build up the speed. The astrodynamics of all that is just extraordinary when you think of the computation.
Yeah, I'm just trying to think of the name of that mission that they're sending to, is it Mercury? And they've had to do slingshots around Venus 3 or 4 times or something like that.
Yes, that's right. Is that Bepi Colombo?
Yeah, it might be. Yeah, that rings a bell. Yeah. But that's a good example, because it's harder to go to the inner solar system than it is to go to the outer solar system. Isn't that right?
Yeah, that's right. You've got to lose velocity to do that. Yes.
Oh, that's right. It's a braking maneuver, not a slingshot. But they have to do it a few times.
But it's the
same concept.
Yeah, the same phenomenon. That's right. Am I just let me?
You got to double check now, haven't you?
Just make sure I've just got to double check. It's planet Mercury. That's right. So it is Bepi Colombo. Yeah, I was remembering correctly. Yeah.
All right. Well, my brain must have worked for a bit there, because I had the right thing in my mind. But there you go, Paul. It's the movement of the planet that makes the difference. Thanks for your question.
Exactly right.
Yeah. Now, one thing I want to mention before we wrap up, I want to send a shout out to Marie Claire, who's one of our biggest fans, listens to us every week. She sent a notice out on the Space Nuts podcast group Facebook page to let people know that they can get their name on the Europa Clipper mission, which is
okay.
Yeah, so I've done that, and so
of course,
yeah. So if you would like to add your name to the Europa Clipper mission, just find it on the NASA website, I'd say, and yes, or you'll find the link on the Space Nuts podcast group Facebook page, because that's where Marie Claire posted the information. And so if you want to add your name to the growing list of people who are going to follow this incredible mission when it finally gets going. Don't forget, if you've got questions for us, you can send them to us via our website. We'd love to hear from you. Don't forget to tell us who you are and where you're from. We'll take text and audio questions. And, we're always looking for more. So, get them to us whenever you like. We might not get the latest ones on until the new year, because I think we're going to do one more show before we have a little bit of a break. And we'll run some repeat episodes and get back together in the new year. Fred, that's
Andrew,
just...
Can I do a shout out?
Oh, yes. There was one more thing, wasn't there?
There was, yes, thank you. Which is just to mention, as many Space Nuts listeners will know, my other half, Marnie, runs a tour company called Dark Sky Traveller, and she has a tour coming up to Texas and Cape Canaveral next year to witness the April 8th, I think it is, total eclipse of the sun. I'll be there too. Between the 1st and the 11th of April, we'll be doing the Totally Texan Total Solar Eclipse. And you can find information on that on the Dark Sky Traveller website, which is just darkskytraveller.com.au. That will give you all the details. Plus, there's actually a trip coming up before to Canada as well, that you can dovetail the two together if you're really keen.
Awesome. Yeah, great places to visit, having done it only very recently myself. And I think where you will be, the totality will be 4 minutes? of total.
Yes, that's right.
Blackout?
We'll be on a ranch in Texas, a private ranch in Texas, which is going to be really good.
How exciting. I'm going to have to hold out till 2028 when we actually have one in Dubbo.
Yes, you do.
It's going to be
We'll all be coming to see you there.
Yeah, at last. I had to arrange an eclipse to get you to come here, Fred. Good grief. All right, thanks, Fred. Always good to talk to you. We'll catch you on the next episode.
Sounds great. Thanks, Andrew. Take care.
All right. Fred Watson, astronomer at large, part of the team here at Space Nuts. And of course, thanks to Hugh in the studio for just sitting in the dark as he always does. And from me, Andrew Dunkley, good to have your company. Looking forward to joining you again on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.